All right, I think we can start. First of all, thank you very much for joining us today. We really appreciate that you are taking your time to watch our webinar. This is, I think, the fourth webinar already that we do for our customers. And today we do it together with Dr. Fabian Karbach from the Scheu company. And we will talk about the advanced aligner foils and their impact on aligner design and the usage. So the agenda is the following. We're going to talk about the mechanical properties of the CA Pro. This is the material that's been released recently by Scheu, and this is going to be the part that's going to be covered by Dr. Fabian Karbach. And later on, Mr. Danai, who's in charge of the business development of Exceed, is going to talk about the cost effectiveness of advanced aligner foils. So let me introduce Dr. Fabian Karbach. So he's going to start the presentation. Thank you very much.
So yes, thank you for the introduction. Now you should see my slides.
You can see your slides.
Perfect. Yeah, my name is Fabian Karbach. I'm a chemist in the R&D department of Scheu, and in the following slides I will present to you our new product, CA Pro, and illustrate the mechanical properties which make the material a good aligner material. First, I want to tell you something about the foil composition and indication. The foil is a three-layered foil composed of two hard layers on the outside, which are made of copolyester, and a TPE layer in the middle, which is a soft elastic material. The material is available in three thicknesses: 0.5, 0.625, and 0.75 millimeters, and it's indicated for the correction of malocclusion by aligner therapy. One contraindication we have currently is that CA Pro cannot be used with acrylic monomers, so it will not be possible to attach screws or wire elements to aligners. Now, when we started our pursuit of a new aligner material, one important property we wanted to improve with the new material is how well and enduring the force is transmitted to the teeth. And the way we are testing that is with a Flexural testing setup. The setup is placed in a water bath at 37 degrees to simulate physiological conditions. And we are simulating aligner treatment by a simple Flexural test. The gray bar here is the aligner foil, which is supported by two tips. And on the top, we have a tip which can be moved down to deflect the aligner foil. So to translate that to aligner treatment, this tip would represent the tooth we are aiming to move. The tip is attached to a force sensor. So when we bend the foil, we can measure the force which is pushed from the foil towards the tip. Now, when we stress a polymer over a long time, there's some effect which is called stress relaxation. So this means initially we have a force between the tip and the polymer, but over time this force will decay slowly because the polymer is slowly yielding under the stress and moving backwards in the opposite direction. And the aim of making a new aligner material was to find a material which is less prone to this stress relaxation, meaning that this force decay is less pronounced, which would then mean that there's more constant force applied to the teeth which should lead to a more efficient aligner treatment. Now, when we compare a conventional aligner foil with our new CA Pro, in this test, we see initially the conventional aligner foil has a much stronger force than the CA Pro, which is good. Lower initial force means that the patient is having less pain when he initially puts the aligner on. And when we look at the force decay over time here in a relative graph, we see that the CA Pro is less prone to this force decay, which I described earlier. So while the initial force is lower, the total force which is transmitted during the treatment stays more constant, which is leading to a more efficient aligner treatment. Now, this is a very static experiment. So we bend the foil, we look how the force is behaving over time. Another experiment we did was cyclic dynamic testing of the foil. So we are not only bending it once, but we are bending it for 16 hours, then unloading, removing the tip, leaving the foil to relax for a while, and then starting the cycle again, bending the foil, waiting for 16 hours, looking at the force, how it behaves, and then removing the tip and following this cycle 7 times. So now we can study the force decay over time, but we can also look at the deformation which is maintained after the loading cycle. So let us first look at the force over time. So now we don't see just one decay curve, we see 7 curves. So both foils again start at 100%, and we see, similar to the previous experiment, the conventional aligner has a stronger decay of the force than the CA Pro. Now there's a gap. This is the time where the foil is not stressed, and here the second cycle starts. You see there's some recovery of both foils. So they don't start at the low force, but they start at a higher point. But again, after that, we see a decay. And over all cycles, we see that the conventional aligner foil is actually dropping faster than the CA Pro. So confirming that also over a longer time frame, CA Pro maintains a higher force on the teeth. Now, a second thing we saw in these experiments is plastic deformation is more pronounced with conventional material. So to illustrate that in this scheme, we start with a flat bar, which would represent the setup of the aligner. We bend it for 16 hours and then we unload it. And what we see with the conventional aligner foil, it keeps far more of this deflection than the CA Pro. So conventional aligner foil suffers far more extreme plastic deformation than CA Pro, which means that CA Pro maintains the contact to the teeth longer and therefore transmits the force over a longer way of tooth movement. Now, besides of the scheme, I also want to show the actual results and numbers. So what we see here is the plastic deformation of the aligner foil, which is suffered by during these load cycles. 0% means no deformation, so the aligner maintains its the initial form, which is the setup which you want to reach during the treatment. And 100% would mean the aligner is completely deformed and actually took over the status of the teeth we want to change. So both foils start at 0%, perfect aligner, but already after the first load cycle, the conventional aligner material has suffered almost 50% of deformation, meaning that the aligner actually lost 50% of the potential tooth movement. And over all 7 cycles, the conventional aligner loses or deforms 70%, while CA Pro initially loses 30%, but levels off at about 50%. So CL Pro transmits force over further tooth movement. So to conclude my presentation, CL Pro provides reduced initial forces, which means less pain for the patient and higher patient compliance. And it delivers a more constant force plateau over the duration of the treatment. And the transmission of the force goes over a further way of tooth movement. With that, I want to end my presentation and hand the word over to Danai. Thank you very much.
Thank you, Dr. Kaubach, for this very detailed presentation, highly informative. And let me just share my screen here. A few words about myself. I'm the co-founder of Exceed back in 2013. Before that, I was with Cadent, the maker or the developer of the iTero intraoral scanner, and then later on with Align Technologies, following the acquisition of Cadent by Align Technologies, and then from 2013 again with Exceed, focusing first on bracket placement design, and then gradually moving our attention to aligner design. Before we move on to cover the issue of advanced foils in the context of align manufacturing, just a few words about Exceed. So we have a few activities that are supposed to help aligner makers. One of them is per patient design services. And the objective here is really to provide detailed designs, 3D plan designs to our customers. And our customers use them to basically produce high quality and affordable orthodontic aligners and bracketing trays. Just a few facts about our aligners design activity. Since 2016, we have provided more than 60,000 per case aligner designs. On our team right now, we have 37 what we call smile designers. Those are certified dental technicians that have to go through some pretty rigorous digital design training until they become what we call Exceed certified. That means that they're qualified of generating plans themselves. Each and every plan generated by this dedicated team is supervised by a separate group of clinical QA QC team. And right now we have on board 6 supervising clinicians. They could be either orthodontists or dentists with some really deep aligners background. And they essentially control the releasing of the designs to the ultimate clients. So they're the ones who have the final word on whether the generated design would actually be delivered virtually to the customer. We also run a dedicated support desk covering the working hours of Eastern Standard Time. Selling globally, mostly in North America, obviously in Europe, Asia Pacific, very recently Africa, very interesting market. We do our designs and also run the communication between us and the clients on proprietary software platforms. Also running MyExceed, which is basically a portal to upload and manage cases. And also for our production partners, we also maintain an ERP-like system that enables them to overview or oversee a number of accounts. Our customers typically are divided into 2 groups. Majority would be dental and orthodontic labs, where Exceed services are mostly provided under a private label. And then the other group, and that group is definitely growing, is growing over the last few years. We're talking about individual orthodontic and dental offices that have their own 3D printers and are manufacturing the aligners and the bracketing trays in-house, and they're getting the services from us under the Exceed brand name. Just a few words about our approach to aligners design. So our business model is really based on designs only that are sent to the customers, and then they have to ultimately lead to successful treatments. And because we don't control manufacturing, we actually consider ourselves as a second generation aligner vendor. The first generation will be the traditional aligner makers. We only handle design, we don't handle manufacturing, and that's why we have to be conservative by default. We have to assume, I don't want to say worst case scenario, but we have to assume a standard manufacturing scenario. So have to be really conservative, and we believe that focusing on providing high quality and careful planning, and also some very assertive quality assurance and quality control, at the end of the day, all of this will be leading to fewer mid-course refinements or mid-course corrections. We think that a lot of these that may be experienced with some of the other vendors may be avoided by really careful planning. If we compare Exceed to some other software-only solutions, I could mention 3Shape or Maestro. I would say that as a per case service providers, we are informed when corrections are necessary, when sometimes treatments go off, which we embed that in our database, and we try to use this information and prevent those instances in the next cases. So this is certainly a learning system. It's a learning company. The general approach is to allow 0.25 millimeter increments between the various aligner staging, and also we recommend 2-week wear time. And that's all of this is assuming our end customers are using standard what we call PTG foils, the standard foils that are used like Biolon, like Duran or Duran Plus, like Track A from Forestident. That has been the case until very recently. And what's been changing over the last, I would say, 5 to 6 months is really the emergence of some affordable advanced multi-layer foils. I think the CA Pro from Scheu, we're completely two independent companies. But one thing that we have witnessed is again the quality of the solution from Scheu Dental, the CA Pro. And if we're looking at the aligners market overall, and I think there's a marked difference between the premium providers and maybe some of the other players in this segment. And one of them is really the type of foils that's being used. And just kind of citing a few examples here. Invisalign, they've been using SmartTrack since 2013, investing millions in developing this highly programmable material that really kind of really improved their the performance of their aligner solution. And interestingly enough, until 2013, when they moved to SmartTrack, Invisalign was using another multi-layer foil, which is called Zendura. And the same company that made Zendura was just acquired last year by Straumann, no other than Straumann. That's the parent company of ClearCorrect. And guess what? Just a few months after the acquisition, ClearCorrect came up with the announcement that they have a new multi-layer foil, which is called Clear Quartz. Nobody admitted it to be, but we all believe this is essentially a rebranded Zendura FLX. So again, another kind of example of high emphasis on quality materials, quality foils. And maybe the last one in the list is Onco with their Spark solution. And again, they've been focusing and really stressing the superiority of their true gem material, another multi-layer PTU type of foil, and that's since 2019. So I think the trend here is very clear. Some of the leading aligner brands are really focusing and stressing the foils that are used in the process. I think Dr. Kaubach gave a great presentation and an explanation of why the PTU foils are superior versus the standard foils. But just to sum it up, we're seeing that forces in those foils are applied over a longer period of time. They keep the potential for a longer period. And that's obviously highly significant in aligners design and planning. Also, they're softer and therefore less prone for breakage and more comfortable to wear. So there's less of an issue of patient compliance and also any complaints from patients. And something that Line has been very vocal about, still needs to be proven on our side. I will touch upon this later. Is the claim that they are at least their foil is more predictable and can be programmed more consistently, again, in the context of aligners manufacturing. So there's a whole kind of a list of advantages or upsides in using those foils. The downside, the key downside, is the fact that they're significantly more expensive than the standard ones on average, depending on the market, but pretty much 6 times more expensive for a single foil. So when we started our research, and that was also initiated or incentivized by one of our production partners that came to us 6 months ago and said, look, we want to use a multi-layer foil for all of our cases exclusively. So we started, questioning, first of all, our PTU foils cost effective? Is the investment, not the investment, is the cost at the beginning of the treatment, does it make sense just from a production standpoint? So what I'm going to be doing right now is I will present, this is by no means a thorough research, but I will be presenting 4 cases where we actually did or provided two aligner plans, one with using the standard material, and the other the advanced material, what we call accelerated staging. And for that mini research, we've used a few assumptions. First of all, the cost of producing a standard aligner would be around $10 per aligner, and then using the multi-layer material, that would be $13. And again, that's assuming a pretty low, well, comparing on the environment, but that's assuming 5 aligner cases a month, or on average 200 aligners. Obviously, if volume goes up, then those costs will go down. And that's also excluding any design fees that are involved in the process. So whether you're getting services from Exceed or from another third-party vendor, or if you're designing the case yourself using an aligner software, this part obviously has some fees, but it's excluded for our purposes. So let me just quickly open the first case. And okay, so what we're using now is we're using the doctor's site, and this is what we call the Exceed 3D viewer. And essentially, I'm going to be just giving a few points about each and every case, and then comparing the two setups. So you can see here, you can see how this case this case is really about alignment of the interior region. And if we compare this case with the possibility of working with braces, then if we would have used braces in this case, then there would be some reaction forces on the posteriors. And in this case, we have a pretty nice intercuspation. So there's really no need to touch the posterior teeth. And this is, in a way, an advantage for aligners, because you can really program and design alignment for the interior only, and still do that. Second point is that the angulation of the interior teeth, that could be easily corrected by using attachments. So, Exceed gives you the full prescription for the case, for placing the attachments, which type and where. And we're also able to keep using attachment, keep the pretty nice torque that we already have in the case. So not a problem there. Going back to the case itself. So the case itself for the standard setup, that included 43 aligners. And then for the accelerated setup using the advanced foil, it went down to 25. So you can see the staging reduction is more than 40%, and production savings were just over $100. So just on the production side, we can save some significant amounts here by using more advanced foils, but then using also fewer stages. Moving on to the second patient, and let me just open this case here. Again, this case is about space closures. And I'll just zoom in, and in essence, in those type of cases, bioprotrusive cases, retraction is a treatment. So I'll just run the simulation for a second. Retraction is a treatment that can really help the patient profile. And in these cases where there are a lot of spaces initially, the aligners could be a pretty effective tool. They can create a rigid anchorage on the posterior teeth. So no movement, again, no movement should be programmed, or it has to be programmed on the posterior teeth. And because of that, closure of spaces using aligners and the retraction could be done very predictably. Second point is that we see on the lower arch, we see that how the lower attachments in combination with the retro inclination, they can help us to achieve, I'll just turn this small, to achieve a really optimal overbite, and that could protect the posterior occlusion when the patient performs protrusive movements. And also the last point on that is that with a little amount of IPR, and again, Exceed gives you the whole prescription of the IPR, and also detailed kind of list of when the IPR has to be performed and how much per stage. So with a little amount of IPR, the torque of the upper anterior teeth can be addressed in a pretty simple fashion. If we go back to the economics of this case, we're seeing initially.
I think that you stopped your share screen. Can you?
What's that?
You stopped sharing the screen. All
right. Okay. Cool. If we're seeing the economics here, then go back to the second case. 44 aligners for the standard case, and then a very significant reduction of 24 aligners, so a total of 20, just 20, achieving the same result. So more than 50% reduction in state.
Can you share the screen again? We don't see the presentation.
All right, is it okay now?
No.
Okay.
Let me share it from my screen.
Okay.
I think you're on this slide, right?
I'm on patient number 2. If you want to go back for a second.
Mm-hmm.
Yeah. So we talked about the more than 50% reduction in this case, and that really translated to $180 of savings just on the production costs. Okay. Constant, can you move to the next slide, case number 3, please? Yes. And click on the link so we can see the setup. Right. Let's just keep the 3D viewer and go back to the presentation. So patient number 3, we're talking about a case of anterior crossbite, and then some angulated canines. I'll be able to share it with you later on. You can see the savings here, 41 using the standard approach, using the standard aligner, and then with the more advanced foil, we got it down to 27. So 34% reduction in the staging, and also that really translated to almost $60 in savings. And the last and final case, patient number 4, Constantine, can you click? Yes, that really amounted to more or less the same savings. So you can see that the savings are pretty consistent overall. Again, not a by no means this is a peer-reviewed survey, but we can see consistently all across the board that staging using the advanced foils allow us some pretty significant reduction in staging. Can you move to the next slide, Constantine, please? So in summary, we believe that even when factoring the higher price, and this is a truly a more significant, dramatically more expensive price for those advanced foils versus the standard ones, PTU foils, and that could be either CA Pro or some other advanced foils that are out there. PTU foils are in general more cost effective than PTG ones, and that is really due to the fewer stages that are necessary to complete the treatments. And we also believe that enhanced patient comfort and fewer breakage issues, and also the shortening of the treatment durations, they're all added bonuses. Regarding the improved treatment predictability, that is being tested right now, and essentially we're testing two groups and seeing essentially seeing the percentage ratio of refinements that are needed, and understanding how our PTU setups more predictable than PTG ones. We'll probably do a follow-up webinar on that point as well. To sum it up, we think that there are a few foundations for successful liner treatments. One of them is really careful and meticulous planning in advance before the treatment begins, a detailed plan, and also a second point is the usage of high quality materials. And we believe that the combination of exceed planning and using multi-layer CA Pro as your aligner fold, it can really truly guarantee high quality aligner solution. And we feel it is truly comparable with some of the other solutions that are offered by other aligner brands at a much more cost effective manner. With that said, I'll turn it back to Constantine for the Q&A session.
Thank you very much, Nir. So if you have any questions, there is the chat and there is the Q&A session, whatever window you prefer. Feel free to ask us questions and we will be happy to answer them. Okay. So Dr. Hütermann is asking, what size are the steps with the new material?
Right. This is something that we'll still have to determine. We don't have a set decision at this point. This is still something under investigation. But let me just say that in the we're now adding a new feature in the Exceed portal where there will be a selection for, and we've never done this before, there will be a selection when you're doing the case submission, there will be a selection between single layer foil and multi-layer foil. So this would be taken into account already in the staging process. Regarding, I would say the general approach to accelerated planning, this is something that we'll publish later on. This is still under investigation, but I would say you can already see some of the staging savings in those 4 cases that I've presented. They all range between 30% to 50%. So we believe that the increments would be affected accordingly.
Thank you very much for the question, Dr. Hütermann. Dr. Ziegler, I think that you had the same question, I believe, right? Yes, so the question was pretty much the same.
Yeah.
So another question, what is the suitable thickness for CA Pro? 0.75 or 0.5?
At this point, we believe it's 0.75.
Okay. Another question, how much tooth movement you achieve in PTU per aligner to reduce the number of aligners?
So I think it goes back again to the previous questions. And again, I want to say this is a fairly new topic from us, which is still under investigation. It is still being programmed and learned. So I cannot give any exact details, but I think again, a good idea is the fact that you can see the reduction in staging that was presented in those 4 cases, and I think the same proportions will be used to accelerate the increments. But again, we'll come up with that later on when we have some established data.
Thank you. The next question is, Dr. Roots has a Drufa Smart Scan, but looking into the CA Pro, the heating times aren't available. So where can we get the heating times and the instructions for vacuum forming?
So it's a different thermoforming device, or do I understand right?
I think maybe there is. I think it's the vacuum forming device is a Drevomat. I think that is the question, but I could be wrong.
That's a good question because we don't have all the heating times for other machines. So I unfortunately cannot advise anything. It's coming down to try and error if you are not using a Scheu machine. But a good estimate would be comparable to standard PETG, 0.75. The same heating time should be sufficient for CA Pro.
Thank you very much. The next questions, are these foils available in 120 diameter?
Repeat the question.
Are these foils available in 120 millimeters diameter?
Not yet. So we are just covering 0.5, 0.625, and 0.75 because that's the common aligner thicknesses. We are not yet planning to make 1.2 millimeters.
Okay.
You mean the diameter?
Exactly.
120. Yes, that's available. Yes, sorry, I misunderstood. I thought the thickness. No, we have discs also 120 millimeter. That's not a problem.
Okay. What does PTU and PTG means? Neil, if you can cover that.
Dr. Kaubach, can you help me out? Because I always refer to them as single versus multi-layer, but what do they stand for?
That's the types of plastic. PETG is a polyethylene terephthalate with an additional glycol, so it's a modified PET. And TPU or PTU is a thermoplastic polyurethane. It's a thermoplastic elastomer, which in this case is the middle layer of CA Pro.
Okay. What thickness of foils do you use? I think we answered that. 0.75. Hello, everyone. I'm currently a student studying dental technology. Is there any courses for the dental technicians? We have a course for the aligner treatment for the doctors. If that's something that is, can be helpful for you, I can send you a link. I don't think we have any courses right now anymore.
Yeah, I think we have all the emails and everything on the last slide. So,
okay, sure. Do all directions of movements improve of the new material, or are there any difference between angulation and inclination?
We're seeing overall improvement on all vectors. Not a difference between angulation and inclination. So we're seeing improvement regardless of the vector identified or the vector that's looked upon.
I think we're done with the questions. If you have any more, just feel free. Oh, there is one more. How much maximum rotation can one give in one aligner?
Right now with the new material?
It's not specified in the question. I think with the new one. Yeah.
With the new one, again, we'll have to come up. So on our website, if you look at the Exceed Aligners guide, we have a very detailed user guide, and there we specify the list of all movements in all directions, in all vectors, and we'll obviously have to update that with the new materials. So right now, this is available for the standard single layer foil. We need to come up with the data for the multi-layer.
I'll send this document to you, Dr. Tari. No worries. I think we're done. If you have any questions, our contacts are here. Feel free to send them and send us an email, and we will be happy to help you out. I thank you very much, Nir and Dr. Karbach, for your very useful and informative presentation. Thank you very much for the attending the webinar, for taking the time, and we'll see each other next time. Thank you.
Take care. Have a great evening.
Thank you for your attention.
Bye-bye.
Bye-bye.
Bye-bye.